Let's investigate another example of using the cylindrical shell method. Find the volume of the solid of revolution. It's obtained by rotating the region bounded by and for this example, we're going to have y is equal to 0, x is plus or minus 1, so x is equal to 1 and x is equal to negative 1 are separate bounds. Y is equal to x squared plus 1, and we're going to rotate that region around the axis x is equal to 2. So again, let's start by drawing a picture of the region, and then we'll get a better picture with the axis. So my rough sketch, we have y is equal to 0, so along this horizontal line here. Alright, we have x is equal to negative 1, and x is equal to positive 1. And then we have y is equal to x squared would be a parabola, and since it's plus 1, that parabola is lifted up by 1. So it starts, if we plug in 0 for x, we get 0, 1. If we plug in 1 for x, we get 2. So it'll be like this right here. So we're going up 2 is the height of both of these points right here, but the region I care about is the one underneath. So now that I have a sketch of my region, to keep things nice and clean, I will redraw it over here. We have our region. It goes up a height of 2, dips down to 1, goes back up to 2. And then we have our axis, which is at x is equal to 2. So this is at 1, so out here at 2, I'll draw my axis. Okay. So again, let's notice that this is a really tricky problem if we wanted to use the washer method. In fact, technically speaking, we can't do this directly with the washer method because the region doesn't have a well-defined inner and outer radius. If we picked a y value high enough, let's say right here, then we'd actually have a couple of washers involved. We'd have the washer on the outside bit of the region and the washer on the inside of the region as well. And we'd end up getting like a washer within a washer. And so you could do this, you would just have to split up into two parts. You take the right part of the region and the left part of the region and then calculate them separately. And it's just a big old mess if you kind of consider what this part of the region being rotated around as such would look like. So we'll have to back up a little bit here. What we'll do instead is we'll pick an x value. And if you like dealing with functions of x, that's kind of your rule of thumb, is that you want to use the cylindrical shell method if you have a vertical axis and you want to pick an x value. So let's pick an x value right here maybe. Okay. So I happen to pick this x value. And so here's my region above that x, and if I were to rotate it, I do get a cylindrical shell. So now I want to know two things about the cylindrical shell. I need to know about the height of the shell. I also want to know the radius of the shell. And again, the radius is always, for cylindrical shell method, the distance from the axis to the x value. All right, I do know that the distance from the y-axis to x is x itself. So I know that then the radius is there, and I know this entire distance, 0 to 2, that's a distance of 2. So I can solve. I know that 2 is equal to x plus the radius, and so the radius would be 2 minus x. So I've got my radius. That's good news. What about the height? Well, the height's pretty simple because it just comes from this curve. I want to know the distance from the x-axis up to the curve, and the curve is given by y equals x squared plus 1, right? So that's would be this height exactly. Height is equal to x squared plus 1. So I've got my height and my radius. We'll put it all together into the formula. So let's see here. The formula says that volume is the integral from, now we need to go from the leftmost x value to the rightmost x value inside of the region. So -1 to 1. I can factor out the 2 pi if I like. And the most important is I plug in the radius, 2 minus x, times the height, x squared plus 1. And from here on out, it's just a calculus 1 integral. I get the 2 times the x squared, 2x squared, negative x times positive x squared is negative x cubed. Then we have 2 times 1, haven't done that one yet. And then negative x times 1 is negative x. None of these combine, they aren't in order, but that's alright. I'll just integrate 2 pi, and we'll get, well, I'm integrating, so now my integral sign goes away, right? 2/3 x cubed minus 1/4 x squared, sorry, x to the 4th, plus 2x minus 1/2 x squared. And we're going to run that from -1 to +1. Alright, so I'll plug in the top, 2/3 minus 1/4 plus 2 minus 1/2. Then we'll subtract away, plug in the bottom. We need to be careful, when is it negative, when is it positive. The negative into an odd power stays negative. -1/4, but the negative goes away, so that's minus 1/4. There'd be a -2, and that would be a -1/2. The negative stays, but the -1 squares away. Alright, and then we can cancel a few of these. I see a -1/4 minus a -1/4. And I see a -1/2 minus a -1/2. But the others combine, 2/3 minus a -2/3, those add together. So that gets me 4/3. And then we have plus 2 minus a -2, that's plus 4. So I've got 4/3 plus 12/3, 16/3, that's 32 when you multiply by the 2, pi over 3. And that's the volume of my region.